So, let us take a problem. Now, it is specifically written here, using the cylindrical cells method, find the volume of what? Of the solid which is generated by revolving the region enclosed by the curve x equal to 3 minus y square, line x equal to 3, line y equal to root 3 about the x axis. So, first what is the region? Okay. We have x equal to 3 minus y square. So, that looks something like this, a parabola. Okay. Now, where does it cross the y axis, where does it cross x axis? When x equal to 0, y is root 3 on the top, similarly minus root 3, but let us take one side only. It is any one of them we can take really, because it will be solid we will be obtaining. So, let us take in the first quadrant itself. So, y is root 3 here, and when y equal to 0, x equal to 3. Okay. So, we want to see the region enclosed by the curve 3 minus y square, the line x equal to 3. So, line x equal to 3 and the line y equal to root 3. So, the region bounded by them is this shaded one, which is the right, not inside that parabola, it is outside. This is the region, and this region is revolved about the x axis. So, there is no need to take this below, the picture below it. Anyway, it is revolved. So, one side we can take, and it would look something like this. This is the solid. Solid will be coming this way when it is revolved about the x axis. Okay. Then what is the cell radius? What is the cell height? So, now you see, you take any point, it is revolving around x axis. So, we should start with taking y, right. So, once you take y, well, let us go back to the picture. You take any y here. So, that gives this distance as your cell height, and what is the cell radius? It is from the axis. So, that will be the cell radius. So, cell radius is y, and what is cell height? Cell height is the point on the curve which gives you x corresponding to that y, which is 3 minus y square. This distance is 3 minus y square, and the total distance is 3. So, this particular distance, which is the cell height, should be y square, right, and cell radius is y. So, that gives 2 pi y into 3 minus y square, it is y cubed, it is y times y square. So, that gives integral, and y varies from 0 to root 3. So, volume is 0 to root 3, 2 pi y cubed dy, fine. So, that is easy to integrate, that gives pi into this is y cubed. So, 2 pi into y fourth by 4. So, that simplifies to pi y fourth by 2 to be evaluated at 0 and root 3. So, essentially root 3. So, that gives you 9 pi by 2. Here also you can do it by the disk method, fine, but we are asked to do by cylindrical cell methods. You can still do it by disk method and verify whether the answer is same or not. Okay. So, let us go to next problem. We have the function given as g of x equal to tan square x by x for x not equal to 0 and g 0 equal to 0, right, because at 0 this tan square x by x is not defined, we redefine it, say g 0 equal to 0. This is the function. Now, we have the region bounded by y equal to g of x, the lines x equal to pi by 4 and the line y equal to 0, and this region is revolved about the y axis, right, revolved about the y axis, revolved about the y axis. Then we want to find the volume of the solid so generated. Okay. So, let us look how does it where the region is. So, the function is y equal to tan square x by x and 0 it is 0, and we have the line as x equal to pi by 4. So, you may limit all our focus to x less than or equal to pi by 4, and in one of the quadrant it is enough anyway tan square x. So, it is remains positive there. So, when x is positive we have this is the region x equal to pi by 4 and the curve crosses it at that point which is y equal to 4 by pi, right. Once you put x equal to pi by 4 that gives you 4 by pi, tan is 1. So, this is how the region looks like. Now, this region is revolved about the y axis. So, it is revolved here about the y axis, right. So, that means you can also use disk method here to get the volume of the solid so generated, but let us use this. So, now if you take the radius of revolution at any point say x. So, radius of revolution is this one, it is 0 to x, and what is the height? Height will be this which is up to tan square x by x. So, it is x times that g x, if that is g of x, it is x times g of x into 2 pi integral. Integral should be from 0 to pi by 4, that should be the volume. Okay. So, let us see this x g x is tan square x for 0 to pi by 4. So, the required volume is 0 to pi by 4 2 pi x which is the radius of the cell and g of x which is height of the cell times dx. So, that gives you 2 pi integral 0 to pi by 4 x g x is really tan square x. We have avoided that g 0 equal to 0 thing by considering x g x at a time which is tan square x from 0 to pi by 4. So, we get 2 pi integral 0 to pi by 4 tan square x dx. So, how to get the integral of tan square x? We know how to integrate secant square x, right, because integral of secant square x is tan x. So, we express this tan square x as secant square x minus 1, then integral of secant square x gives you tan x and integral of minus 1 gives minus x. So, it is 2 pi into tan x minus x evaluated at 0 to pi by 4. So, that simplifies to 2 pi into 1 minus pi by 4. So, as you see it is not very difficult to apply it. Now, let us solve another problem. So, find the volume of the solid generated by revolving the region enclosed by the curves 2x equal to y square, 4x equal to y fourth minus 2y square in the upper half plane, right. So, in the upper half plane we have the region 2x equal to y square, 4x equal to y fourth minus 2y square, and we are revolving this region about the line y equal to 5. We want to find the solid of such revolution. Okay, let us look at how does it where does it figure out. So, it is revolution about y equal to 5. So, you should be able to express x in terms of y to get the integral. Now, the first curve is 2x equal to y square or x equal to y square by 2. So, that is this one, the down one, which in the upper half plane it joins the origin to 2 2. 2 2 is a point on this. So, in fact, first thing is to find out, because it is region enclosed by 2 curves, we should find out what are the points of intersection in the upper half plane, right. So, that you can get easily the curves intersect when for which x and y. So, let us eliminate this 2x or x, that is we get 4x from the first equation as 2y square and from the second as y fourth minus 2y square, and that factorizes to y square into 4 minus y square equal to 0. So, y equal to 0 or y equal to 2, right, because we are taking only y greater than or equal to 0, it is upper half plane. So, we have only these two as the solutions 0 and 2. Then corresponding points are x equal to 0 or 2 according to y equal to 0 or 2. So, we have the two intersection points, one is the origin, another is 2, 2. Okay. So, now y lies between 0 and 2, x lies between 0 and 2, of course, we need for y. Now, we go to the solid generated by the revolution of this region about the line y equal to 5. So, y equal to 5 will be somewhere here, the region is revolved around this line. Then our cell radius, you take any y, for that y will be cell radius will be difference between that y equal to 5 and y. So, it is 5 minus y, that will be the cell radius. And what is the cell height? Now, you have two edges, one here, another is here also. So, both the things we must take into consideration, or you can take two solids and then add those two volumes separately, that is also possible. So, that is how we will be getting the cell height. The cell radius is 5 minus y as we have seen, and cell height is how to get the cell height. First thing is, it is really the cell height, this one. So, if you take the first one, say on the right side, it is from y, it is y square by 2, okay. And then on the other side, it is not this curve, it is the other curve, right, x equal to y fourth by 4 minus y square by 2. So, that is the point. So, this one, this length will be at that y, it is y fourth by 4 minus y square by 2, okay, and it is in the negative side. So, we have to subtract it to get the height, or just get this one, this length plus this length, which is same thing as y square by 2 minus, this is negative sign now. So, y fourth by 4 minus y square by 2. So, that is the cell height, which simplifies y square minus y fourth by 4. Then our volume is integral 0 to 2, y varies from 0 to 2, 2 pi, and the cell radius which is 5 minus y, and the cell height which is y square minus y fourth by 4 dy. So, that we multiply out, 2 pi goes out, and 5 minus y with y square minus y fourth by 4 gives 5 y cubed gives 5 y square, then minus 5 by 4 y fourth minus y cubed and plus y fifth by 4. So, once you integrate, you get 5 y cubed by 3. Next one is 5 by 4 into y fifth by 5. So, 5 by 20 y fifth, and next is minus y fourth by 4. Next y fifth by 4, that gives y sixth by 24, right. This is to be evaluated at 0 and 2, subtracted out, and that simplifies to 8 times pi. Okay. So, we go for the next problem. Here we use all the three methods, such as the disc method, the washer method, cylindrical cell method, to find the volume of the solid generated by revolving the region. What is the region? It is bounded by the curve x equal to y square and x equal to 3 y square minus 2, and the line segment joining minus 2 0 to the origin. So, minus 2 0 to the origin, this is the line segment that is on the x axis, and we have the curve x equal to y square. So, it is this one, x equal to y square, and the other one x equal to 3 y square minus 2. So, first of all we should find the points of intersection, right. So, what are the points of intersection here? It has not been computed, but let us compute. So, we have x equal to y square and the other one is 3 y square minus 2. So, that gives 2 y square minus 2 equal to 0, or y equal to plus or minus 1, okay. And this is revolving about the x axis. So, only one of them we can take, the other one will come in the revolution. If you take both, then it will be adding 2 volumes, right. So, we take y equal to 1 as our point of intersection, so correspondingly x becomes also 1. So, 1 comma 1. So, we have a point minus 2 0, where x equal to 3 y square minus 2 crosses the x axis, and the origin where x equal to y square crosses the origin, crosses the x axis. So, that gives the border of the region, one border, and the other point is 1 comma 1. So, bounded by curve x equal to y square, other side is x equal to 3 y square minus 2. This is the region. Now, this region is revolved around the x axis, about the x axis. Okay. So, this is revolved about the x axis. Then you can use the disk method, because one of the side the axis of revolution is bordering the region. So, it will be disk, right, of this type. Then let us use the disk method first. Okay. So, in the disk method, what will happen? This will be the disk radius. Though what is the radius? Say it is x, then the curve is 3 y square minus 2. Okay. So, that gives you pi into x plus 2 by 3. Okay. This is x, this is revolved about the x axis, right. So, it gives pi into x plus 2 by 3 minus pi x dx. Okay. This is x plus 2 by 3 and this is x, which are coming from the disks really. So, this, if you consider this one. So, as we are doing by disk method, first we think of this solid, which is we put one, construct one line x equal to 1. First the blue and white both mixed together, that region, that gives you a volume. So, that corresponds to pi into x plus 2 by 3, and then when you take you have to subtract this volume of the solid, which corresponds to this white region. So, that is x equal to y square is the curve. So, it is pi y square, right, pi times y square. So, dx. So, that is pi x dx, x as a function of y, we are taking y as a function of x here, because it is revolved around x axis. So, it is pi y square, that is pi x dx. Similarly, here it is pi y square. So, now y square is the other curve. So, that gives x plus 2 by 3, that is why pi into x plus 2 by 3 dx, and this simplifies to pi into x square by 6 2x by 3. So, that gives the answer as pi. Now, if you go to Wasser method, there is nothing new here, because there is no hole. So, it is the same as the disk method, you will not get anything new, right. That is what we say, this gives the subtraction of exactly the same two integrals. So, you get the same answer. Now, you go for the cylindrical cell method. So, in cylindrical cells what happens? This is really approximated by cylinders of this type, right, sum of those cylinders. So, it is the other way around. So, here the if you take any, it is revolving around x axis. So, you have to express everything in terms of y, right. So, you take any y corresponding to that y, if you take. So, what is the radius? Radius, cell radius is this one, which is y really, y. And what is the cell height? Cell height will be these 2 points, the length between those 2 points. So, that means we have to compute from 3 y square minus 2 to y square, fine, that should give us the length. So, it is y square minus 3 y square minus 2 is negative. So, y square minus 3 y square minus 2, which is 2 minus 2 y square, that is the cell height, and cell radius is y. Therefore, the volume is integral 0 to 1 2 pi y, which is the cell radius, 2 minus 2 y square, which is the cell height, dy. So, that gives 2 pi, 2 y gives y square in integration, and this is 2 y cubed. So, that gives 2 y fourth by 4, evaluated at 1 and 0 it is 0. So, that gives again the same result as pi as we verify. So, of course, for every problem here you could have used Wasser method, but try that and verify, that is an exercise for you. So, we stop here.